I'm sorry, Jared and Carlos, the mic was turned off. I hope that's better now. Right, so when you hear Pablo talking, that's me, I'm Daniel, hi. So you're doing something like that, right? Okay, perfectly fine, thank you, good. So software supply chain attacks actually target exactly that. So not when it's running in state, right? But the entire process that you're kind of using of producing these artifacts, right? Why are we talking about this? Well, it turns out it's very popular these days, right? I'm bringing a couple of examples today, but let's look at some numbers first. So we see a massive, and these are like 4 different sources, a massive surge of attacks that actually target these specific vectors, okay? We see commercial code bases that have a lot of OSS vulnerabilities. We see, who said that? Sonatype was a 650% surge in supply chain attacks year over year, right? And they reported that in, let me see, I don't find that. It's in the sources in 2021. In just 1 year, 650% year-over-year increase in attacks on supply chains, right? Known attacks. And then, yeah, okay, at some point, we're predicting that and Gartner says that by 2025, nearly half the world's software organization will have experienced supply chain attacks, okay? So it's a huge problem. It's kind of modern. And so how does it look? So same picture, right? Bit blown up, but you can actually attack it at a lot of very different vectors, right? So it can start all the way on the left when you're actually injecting bad code, right? So this is not necessarily speaking just your version control system, but your workstation can be compromised too, right? And then goes all the way towards the right, right? It goes from maybe compromising packages on upstream open source repositories that you're loading and you don't even realize it, and they're just, you know, malicious. Your build system itself can be compromised, right? So if you have a non-ephemeral build system and somebody gains kind of root level access to it, all of the builds that it will produce, or it can produce, right, could potentially be compromised. I could also just hijack the CD system and then either use it to deploy your artifacts, but with wrong configuration, or just inject an entirely new artifact, right? It's kind of scary, right? Most people don't even think about these things because we're so geared about thinking about this part when it actually runs in production. But that's kind of, not a lot of people think about it, and it's not really obvious. I brought a couple of examples to make this more tangible. We all know this. SolarWinds was in the press. Very sophisticated supply chain attack on a, so if you don't know what SolarWinds does, they actually produce software. So they're a software vendor, and they produce network monitoring, so kind of like security monitoring software. They have a lot of customers, enterprises, governments, military even, okay? And that software typically runs in a customer's infrastructure with very high elevated permissions, right, to scan all that stuff. So what happened here is, this is a Windows executable. It's being built on MS Build, Microsoft Roslyn compiler platform. And what happened is that attackers, and we still don't know who it was, they infiltrated the build system itself, hijacked the build system, injected a root level type of hook inside of the operating system. And every time MS Build was executed, it kind of ran a pre and a post build hook, right? So before the build, it would inject its own code into the code base, build would complete, green, and then post, it would remove the code, right? Leave no trace. SolarWinds did not detect that for a long time. They rolled out that software to tens of thousands of organizations. It ran there for approximately 14 months before being detected by FireEye, right? Massively spread, right? So you're no longer attacking one organization, but in this case, tens of thousands of organizations. Very difficult to mitigate, right? So if you write an email to all your customers, hey, security patch, not necessarily everybody does that, right? We know that. So very scary. But if they were using a built platform that was ephemeral, this could not have happened, right? So if they're using like some kind of a container-based platform that runs every step in a container, and the container runtime would check out the image, validate the SHA hash sums, this would have been impossible, right? I can burst. Who builds Node packages or uses Node? Some people, some shy hands here. You know what happens. Jared, can you park your question until the end?
No, he just raised his hand. I think to say that he also is using Node.
Okay. Oh, right. Sorry. Yeah. Yeah, I feel you, Jared. I was being stupid. But Jared, raise your hand if you know this feeling when you're just trying to use this one npm package and then you go npm install and your computer does a whole lot of things. It seemingly downloads half of the internet and it's like, I don't know, half a gig, 60 packages, and somehow 50 of them have critical vulnerabilities and you're just, it's all right. So, yeah, I feel you. So I can burst. Very simple. So anyone can upload packages to npm. So what if I were just to create a whole bunch of packages that look very much like the thing that I wanted to have, but is spelled slightly differently, right? It's not fonts awesome, it's font awesome. And there's like these tiny little differences in between these things. And typically what these things do, they exfiltrate information. Like take all of your env variables from your local machine, because that's where you're running it first, and upload it somewhere. Would be nice if we had a trusted registry that we could download from, right? Where these packages had no chance of survival. Also, never ever store your secrets in environment variables. Just don't. CodeCoff. It's a code coverage service, right, where you can send your code coverage reports to. They had a kind of like a bash script uploader that you could include that in your CI build, right? And basically just run it, upload your code coverage reports to that thing, right? They had, so an attacker actually managed to include that bit into this bash script uploader, and just read the second line, right? So it basically reads out your entire environment variables, tags it with your Git remote, and uploads it somewhere, and then fails silently in case that doesn't work. So if you were to have some kind of like a code signing process in place, or if you were to actually check the hash sums on that bash script uploader, this wouldn't have happened. Don't use the environment variables for secrets, never. Okay, so what can we do about it? So I'm kind of rolling over to something that Google released last year at Next, which is called Software Delivery Shield. Up until now, main takeaway is there's a new class of attacks. It's extremely difficult to detect because nobody's looking for it. We don't have the processes, we don't have the tools, we don't have the practices to actively do that. They're surging, it's going to be more of them, right? Extremely disastrous and wide-reaching and very hard to mitigate, specifically when you're a software vendor and you're rolling it out to other organizations. They trust you to some degree. I mean, they bought software from you, and still it's bad. So it's not a single service, it's not a feature, it's not this one thing that you can just switch on, but it's rather a solution where we wire together features and services, a lot of them being in public preview, into something that's really trying to kind of help you increase your security posture end to end, from writing code to running in production. It's built on Google best practices. So some of these concepts that I'm going to be talking about, we actually do this, we enforce that for everything that's Google production since about 9 years. And it's modular, right? So you implement the entire thing. You can start bit by bit, wherever you think it's most critical. But before we do that, because this is also new, we have to talk about a couple of new concepts, okay? 2. Provenance documentation. It is a specification that you can find on in-toto.io. It's an open specification that Google participated in. And essentially, the point of this is create a document with every build of an artifact that documents the entire way, the provenance, how that artifact has been generated. Right? At the end, it's just fancy for JSON, right? That it's kind of like a receipt that your CI system hands to you. Okay, this is all of this stuff is in there. This is how I did it. And then finally, you sign it with private keys of your build system. That stuff is then being stored as image metadata. Like if you're building a container, the image metadata will be kept around. And whenever you're actually trying to deploy it, you can look at it. Ah, this is how it was manufactured. And it's signed. And I can verify that, the authenticity of that. And we're including things like what was the build system that signed it? So what was the identity? What exactly did it do? So the entire steps, like in sequence, the recipe of executions that happened. Every single input that went into the build, environment variables, configurations, arguments, substitutions for your build system. Metadata on the build, lots of timings, right? There's a lot of hash sums in this document. And finally, the complete, and we call this software bill of materials, right? So if you're manufacturing a car, you need like about 4 wheels and some steel and a steering wheel. And that's the bill of materials, right? So we're documenting exactly what kind of source went into this. Is everybody with me so far? Yeah? How about you, Jared?
Yeah, June, just fine. Thank you.
Yeah.
This reminds me of the Microsoft install shield, for the record.
Nobody can hear you, Jared. This is a bit weird. Sorry, there's no speaker on the other end. Next concept, salsa. So I have been told that at this point, any Google speaker has to make a joke about guacamole or salsa or sauces in general, but it's not about that, right? So it stands for supply chain levels of software artifacts. It's another open standard that essentially tries to rate the security posture of your entire SDLC for a particular build process, okay? 4 levels, there's 5 levels that you can get. There's also level 0, and I'll walk you through this, and I'm gonna read this out. So level 0, no guarantees. Salsa level 0 is essentially you're compiling something locally, and then you email it to somebody that you don't like. Salsa level 1, the build process must be fully scripted or automated and generate a provenance document. If you don't generate provenance, you will never even get to level 1. An example here would be you're running a make file locally, make script, you're executing against a make target, you're producing a binary, and then the provenance kind of also sits next to it. Level 2, you're using version control and a hosted build service that generates authenticated provenance. So it has a signature, the provenance document. So you store stuff on GitHub, triggers, cloud, build system runs. They're both remotely hosted, and that build system then signs the provenance that it generates with its own private key. Level 3. The source and build platforms meet specific standards to guarantee the auditability of the source and the integrity of the provenance, respectively. Source and build platforms have been audited to be proof of temper resistance proof, and they are protected against things like cross-build contamination, right? So for level 3, you need to have somebody else audit your build systems and their environments. Up until level 3, Google can help you with these things, and other cloud providers can do so as well. I told you this is not going to be a sales pitch. Level 4 requires a 2-person review, so a human needs to be in the loop. No technology provider will probably give you that because it's a human, and you ideally want somebody in your own organization to be that. And the build needs to be hermetic and reproducible, completely. If I run it again, it has to yield the exact same kind of byte stream of an artifact or fail. Still with me? Cool. If you have any questions now, it's a good point to ask because these concepts are really kind of
Where
important.
most of the organizations stand when it comes to this?
Oh, they don't know.
They don't know. So what are the frameworks that are there that kind of automate the checks to understand which level they are at? Or are they?
I'll show you. Okay, so back to software, software delivery shield. I told you it's end to end, so we're kind of looking at 4 stages of it, right? So while I'm developing code, then while I'm injecting or supplying other kind of upstream dependencies into it, building and deploying the thing, and then finally looking at what we can actually do at the runtime level and how the runtime can enforce certain things that need to be true about that artifact before accepting and deploying it. Right. So I created this demo that kind of walks through the entire thing, right? So on the left-hand side, development, right? Disclaimer. We launched this thing called Cloud Workstations end of last year. And this is the only bit that if you're using it at a large scale, it will generate significant cost for you, right? Because it's actual virtual machines. But think of it like Cloud Shell or Gitpod, but with more beefy instances and more control on your end. So you can actually deploy these remote development environments in your own VPCs and leverage your own security, whatever you have in place. Cloud Code is an IDE plugin for VS Code and IntelliJ, and it's got a couple new features that are going to help you produce more secure code. And I'm going to demo this, okay? Here's Cloud Build. Cloud Builds, I see nodding heads. That's our own fully managed build system. That's nothing new. It hasn't changed a lot. It's been around forever. But there's this other bit called Assured Open Source Software, which essentially is a Google-created registry mirror for popular open source dependencies that you can, with less headache, pull from. Artifact registry, a couple of improvements. There's this image metadata repository where we're storing all the provenance documentation. There's Cloud Deploy, yada, yada, yada. Binary authorization, that's going to be a bit more interesting. It's been around for a while now, but it turns out it's really, really important for this, right? So it's kind of like a trust-based policy enforcement engine that acts as a gate before things like GKE or Cloud Run, right? So I can configure it in such a way that Cloud Run and GKE will actually reject deployments if certain signatures and certain things about that artifact that I'm about to deploy are not true. Okay.
I have a question. Not true or missing or both?
Any other two?
Yeah.
Okay. So I'm going to walk through some of these services and things now, right? So that's in preview, public preview. You can go test it out. But it was very important when we designed Software Delivery Shield that we started at where code is written, because I know you love your MacBooks, but they can be compromised too. There can be like a whole lot of open source software, like maybe you're running your favorite shell, maybe you have some kind of a weird setup, maybe you're using Vim with about 80 plugins. And all of that can contribute to that. So essentially think of like a managed service that allows you to instantiate certain creations of virtual machines that will act as remote development environments. Run in the cloud, you connect to them through a browser or with a local installation of VS Code through remote SSH extensions, or with a local installation of IntelliJ, right, into a remote IntelliJ platform. You can create security policies for them. You can create your own configurations of them. Google supplies base images that are tested. You can supply your own. They run in a VPC. You can use things like VPC security controls. You can use intrusion detection systems. You can use your own firewalls. You can very tightly control these things. If at a later stage, it turns out that one of the packages that you have been running is compromised, Google will tell you, and then you can enforce that. So if you have a team of 10 working with a certain configuration and you know it's compromised, you can enforce an update. Right? So what does it look like? This is Cloud Workstations. It all starts by kind of, you need this resource, which is a cluster. It's kind of boring. I put mine in the Netherlands. And then you start out with some configurations, right? So a security administrator would kind of work through these, or an IT person would work with these configurations, maybe create different configurations per team, depending on the toolchain that they're using. Let's have a look at the wizard. Yeah, you select a cluster. Okay. It's an actual machine running, right? That machine just runs in GCE. So you will be billed for it. So be careful with that. But then down here, you can actually select or customize the environment. So these are Google provided base images. They kind of look like that. So that's Code OSS. It's like the really free open source version of VS Code running in the browser, and all sorts of IntelliJ flavors. You can also choose to not have any IDE there, or run your own crazy configuration, whatever you're into. And that's it. That's how you can basically, on a cluster with a configuration, you can instantiate one of those workstations. It's this one, right? So mine is already running. And then you hit this button, and pops up in a browser, and that's VS Code. It's not. It's kind of like GitHub code spaces or Gitpod, but with more control. Cool. I'm going to open a folder because I built an app. So if you've ever listened to me talk, all of my apps are Hello World. I don't really know how to build anything else. And here's it. It's Python. It's a Flask Hello World Python app. Cool, no? Hey there, GDG Cloud Berlin. Hey. Yeah, so that's workstations. If you're not into browsers, you could connect to this remote SSH from VS Code and have it that way. Cool. Next thing. A new feature for Cloud Code, which is kind of our extensions for these IDEs. And Cloud Code allows you, it's kind of assisting you whenever you're including dependencies, foreign dependencies into your code base. It will look at them and the version and check with our bug trackers if there are known vulnerabilities on them, right? And it also helps you to kind of, circumvent them, helps you also with licensing information. So it's kind of like your legal and security assist straight in the IDE. So let's have a look at that too. So if you have never seen it, this is Cloud Code, this nifty little thing that allows you to interact with Kubernetes, Cloud Run. There's a Cloud API browser in there, Compute Engine, Cloud Functions, so all the runtimes where you could run code mostly. And then there's also Secrets Manager here. Does anybody know why we put Secrets Manager in here from the get-go?
So you don't have to put your secrets in the environment variables yet?
Yes, or even worse, in your code base. If I go like password something here, and I don't know where to go with my secrets, it has a thing to just put it in Secrets Manager, and I don't have to do that. Good. Well, kind of good. Right, but it has this other feature now, and I've brought some other bad apps with me. I brought some bad Java apps. Here's one, right? So you can see that the POM XML is a, you don't know Maven, that's where you put your dependencies. It's red. It tells me I'm using log4j core. And there's a critical, a high, and a medium dependency. And these all are direct dependencies. So that package itself is vulnerable. It also tells me all of them are fixable. And by the way, this is Apache 2 license. Cool. You can look at this in other ways. So there's a whole array of problems, right? So if I just hover over them. So the first one, the critical one, is fixed in 2.16, fixed in 2.17, fixed in 2.17.1. So, so 2.17.1 is kind of like the lowest thing that I should be running. And then I save that, and it takes a couple seconds, and then because it needs to call our services, and then voila, that problem is solved, right? So it's really geared towards getting rid of these things before they even turn into a problem. I have another app here, a Spring Shell. Why do I have Spring Shell? Oh yeah, this is it's a lot of problems. But you see, right, the one thing I want to show is it's not just that single direct dependency, but it's also 93 transitive dependencies, because that package itself is loading other packages. I kind of want to avoid Spring Shell altogether. Yeah, so it's really geared towards helping you make better decisions early on in your development lifecycle. Cool. What else? Artifact registry has gotten a lot better. So this is where you store things like your container images after they've been built and integrated. And it's gotten a lot better at showing you these information. It's really surfacing not everywhere. Also, the container analysis and the container scanning API, continuously running scans across your artifacts. They'll show you more, more vulnerabilities from different sources. And then there's this new guy called Assured Open Source Software. And that's basically that mirrored registry that I was talking about, right? So instead of straight downloading from things like PyPy, where honestly anybody can put images, can put dependencies, Google kind of created a mirror, and we do a lot of things with the most popular kind of dependencies that people would want, include them in there. And we do something that's called fuzzing, right? So you have your piece of software, you bombard it with a whole lot of random input, check the output, check the profiler, and figure out if it's doing something wonky. There's a technology that Google open sourced years ago called cluster fuzz. It essentially allows you to test these packages on a distributed cluster system. We have one ourselves where we're running cluster fuzz, and it's 30,000 machines big, very beefy hardware machines that do nothing else but fuzz open source dependencies and figure out if they're doing something shady. And then if they don't, or if we're like confident enough after bombarding it for a while that it's not going to do anything malicious, we put it in these assured open source software repositories. It's also in preview, so don't expect every dependency to be there. And it's only available for Java and Python. You don't have to pull directly from that. You can run your own things like Nexus or Artifactory as a mirror in front of them. If you're doing that, it's not gonna be a problem. They're also, they're also signed with, Google signatures. Right, let's have a look at it. And what did I want to show? I wanted to write. So I'm just gonna go and show you my code a little bit. Docker file. Look at my base image. I just don't want a Python image. I want Python 3.11.1, but not any. I want Python 3.11.1 built on Debian Slim Bullseye, but not any of those. I'm interested in a specific sequence of bytes that matches that SHA hash. Okay? This is what leads me to reproducible hermetic builds. Down here, I'm doing something funky with pip install. So first off, look at the index rows, right? So one is PyPy, but the first one is Assured Open Source Software, Google's repository. The reason why I have to use both is because not all packages that I'm going to use today are already included in the preview version of the registry. And then there's a bunch of parameters that I'm using. Be verbose. Tell me about everything that happens. I want it on the logs. Don't use caches. Don't just download dependencies that are transitive and require hashes. So let's have a look at that. This is my requirements txt. Once again, I'm not interested in just Flask, not interested in just Flask 2.2.2, no, but that particular package that matches this hash. Okay. It's not something that I can only do with Google's registries, and I can also do it with PyPy. Looks the same. Right? So if you do that, if you start doing that, all of a sudden it becomes a lot harder, because in most registries, people can just, the original author can just go and update GUnicorn 2010, inject something else, and if you don't check the hashes, your build system will not notice it, right? And you don't know how the author of GUnicorn is handling his credentials.
But
Okay.
it's you doing that, right? Not the system.
Sorry?
It's you doing that, right? It's you adding that. You get no help from your system.
Yep.
Right.
No. And I need to supply the initial hash. Right? If it's already compromised, then
Yeah, that's the question.
Yeah. But it was a good question. I see you're paying attention. Cool. And then, so in this case, I'm using Cloud Build, which is Google's serverless build system. This is what it looks like if I'm executing it. So it runs in container steps, right? All of these are ephemeral container executions that only live for one execution. So that means they're checked by the system itself. Build a Docker image, tag it with a short SHA. You could also use a long SHA, depending on how paranoid you are. Push it to artifact registry. Oh, sorry. And finally, also create a release with Cloud Deploy after it's been integrated, because I want to deploy it eventually. And then I basically mark those images here. Right. I could probably just push up my patch. Do I have one? That's modified. The POM is modified. I don't really care about that. Ooh-wee. Okay, push it up to make it remote, and it's gonna cause a trigger to start a new execution of the build system itself. So look at that. There it's running. It's gonna run for a while, so I'm just gonna go to the next thing. Right. So I'm kind of trying to make sure that the base images and all the dependencies that I'm loading during my build process, they kind of match my expectations, by doing rigorous signature checking. And I'm also using this other type of registry where I can be a little bit more confident that not everybody can just upload random stuff, and it's been tested. Cool, Cloud Build. Cloud Build, in most cases, if not weirdly configured, will actually already give you Salsa level 3 builds, because now out of the box it generates this provenance, and it signs it, and it's audited, and it's tamper-proof, and it's ephemeral. So it's very easy to get there, and why not use it if it's that easy, right? So it creates this non-falsifiable authenticated provenance documentation. It's been audited by a third party. Also, the source control systems most of them are. If you're using GitHub, that works fine too, because that actually qualifies as Salsa level 3. But it does this new thing where it shows you information about the build. So maybe my build is done by now. Nope, it's not. I was talking too fast. Let's look at a historic build. It's the same one. I ran it this morning to make sure the demo still works. Right, so it's a different view of the YAML. Build container image, tag it, push it, create deployment. So I see all the build log, right? I want that. And if we go here to build artifacts, there's actually 4 artifacts. The build logs that have been saved on cloud storage, I can expect later or ingest it somewhere else. And then 3 images, it's actually the same. It just has 3 different tags, 2 different tags and the untagged version. So I'm going to go to this, the one that I specifically tagged with the short SHA of the git hash. And I look at it, and this thing slides open, and it shows me a whole lot of things about my artifact. It tells me about all the vulnerabilities in here. It's not all the vulnerabilities that it shows today. It shows you only Linux-based images, Maven images, and Go packages. So if you create a Java build that runs on top of Debian, all of your vulnerabilities should theoretically show up, all the known ones, or vice versa if you're using Go to do that. I'm using Python, so it will only show the Debian vulnerabilities in here. It also creates a list of dependencies, not just the vulnerable ones, but I can export that, and I know what's in there. Right? So these are all the Debian packages in this slim bullseye base image that I'm using. Down here, it links back to the build, the logs of it. And then finally, I've got my provenance documentation. Right? So this is this, it's like, you guys are very far away, so I'm kind of pointing out what's in here. So this is this in total statement, right? The first blob is identifying the subject. Which artifact are we talking about? It's listing the 3 images, which is just 1 image, right? But 3 tags, but the SHA hash sums are the same. Next, it's a provenance type, so identifying salsa provenance version 01, identifying the build system, cloudbuild.googleapis.com/Google hosted worker version 0.3. That's the one who built it. It goes through an object or a recipe list, essentially. What's the type of this? This has been a cloud build YAML defined build. It lists the arguments that went into it. It has an array of all the steps that it executed, so stuff that was in my YAML file. So Docker build. It lists the timing. Right? So it's kind of capturing how long it took for that. Kind of important. If there's a huge discrepancy in there, it means your build system is doing something it shouldn't. It's pushing it, tagging it, successful, yada, 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 yada. That's my recipe. And then finally, I'm going to the source provenance, right? So what's the trigger? What's the version control system that actually triggered this? What were all the options that went into the execution of the build system, right? So in this case, Cloud Build, it's running with its default configuration, default worker pool, all the substitutions that Cloud Build injected in your execution, right? So what's the repo name, revision ID, commit SHA, trigger name, yada, yada, yada. Complete identifier for that execution, the resource, Cloud Build execution resource, so you can identify it correctly. More information about the entire execution itself, so the timing itself. And finally, the complete list of the software bill of materials that went into the thing. That thing is signed, stored with the life cycle of your artifact in Google Cloud, right? And you can always look at it. Cool. Any questions so far? Yes.
So that works only because it's on the Google Cloud Code repository, or also with GitHub?
It works the same with GitHub. And it would also yield Salsa level 3 build, unless you're doing something very wonky with your config.
And if you have a different source repo, then it wouldn't be supported yet, like GitLab.
That depends. I don't know how far we audited those VCSs, but try it. Let me know. Good. Yeah, let's look at some of these vulnerabilities, right? So there were some. Somewhere in here. Right, that's my image. So that links to artifact registry, where my image is going to be stored from now on. Gives you this overview. So it says here, I only scanned open operating system, Go, and Maven packages, but I found 50 vulnerabilities. 6 are fixable. And we can look at, I don't know, this is high. It's affecting OpenSSL, in Debian. So that's on the Google Vulnerability Notes tracker. Directly links to the upstream Debian CVE notice board. And there's a whole lot of text that I don't really get because I'm not really into cryptography. But it advises you that, okay, so Slim Bullseye is vulnerable, which I'm using. But if I were to upgrade and use the security patches, that would be fixed, or use Bookworm or SIP, that would also be fixed. So it's actually actionable. So I know what I can do about it. Right. Goody. Next. Yes. So yes.
So do you have enabled something, or the cloud build by default gives you level 3? Or you have enabled or enhanced?
So depending on your configuration, because of the things that you can now no longer turn off in Cloud Build, like provenance generation, signatures of that, its own state of being audited, right? As long as we can also verify that for the source version control system, probably very likely to be yes, level 3. There is something else that you need to enable. So some of the container analysis and scanning APIs, because they will incur like a minor fraction of cost because we're running something to scan your images, not only upon first creation, but also like over time periodically. We're keeping track of that, right? So I think you need to opt in by enabling the API. Good. So the runtimes have also become a little bit better in trying to assist you in increasing your security posture. So I'm going to talk about GKE first. It looks like that. So there's this new dashboard in GKE that's constantly scanning your entire configuration of your cluster environment, and it's comparing that with hotspec security standards. Right, so that's some kind of an open source security standard for running GKE workloads, and then it tells you, okay, maybe don't run it in this namespace together with this other thing. Maybe don't run it in elevated permissions. And then it actually gets very actionable and recommends things about that, right? How you can improve your security posture. But instead, I'm going to show you Cloud Run because that's easier, and I'm a Cloud Run person, so I'm just going to do that. Right, Cloud Run. So first thing, let's actually look at one of my services, this production service. First thing that I like. All right, so I'm just going to show you this binary authorization that becomes important in about 2 minutes, but it's enabled. And I'm going to talk about what it is. But what I wanted to show you is under revisions. So in Cloud Run, you run like revisions, immutable revisions as part of a service, right? So this is my active revision. And if, in case you ever wondered, like, hey, what is that thing actually running? What do I run in production? The security tab now looks very familiar. It has salsa build levels, and it links you back to the image itself, and you can investigate it, and you see all the dependencies, and you see the build logs, and you see the provenance documentation, right? It's actually very easy to understand, like, hey, what are we running at this very moment? I find it is very tangibly useful. But it does other things too, right? And this is this kind of like machine learning assisted kind of security insights that help you better your configuration while you're at it. There's this thing called security. I'm going to read this out. Your Cloud Run service in Europe West 4 is using the default compute engine service account. By default, this account has a lot of permissions. So you don't want to do that. And then down here is a recommendation to increase the security of your Cloud Run service. Create a dedicated service account with minimal permissions and deploy it. And there's a button here that actually just allows you to very easily follow that recommendation, create a new service account, create a new revision with that service account active, problem solved. Now you might think, Daniel, hey, that's not really software delivery lifecycle security, right? But I'm showing you this in case you actually ended up loading some kind of a malicious code vector into your artifact. This is one of the most effective ways to kind of, kill it in its infancy, right? Because if it would do something that it's just not allowed to do, it's not really that bad. Okay. And next. Am I good on time?
Maybe we could wrap it up soon because I think we just got the pizzas in.
Okay. Last thing that I'm going to show. So binary authorization has been around for quite a while. Essentially, what it allows you to do, it's kind of under the hood. It's a policy enforcement engine, so you can actually tell GKE and Cloud Run only deploy images that have a certain attestation node attached to them, right? So in this case, so what I'm going to show you is Cloud Build, whenever it integrates an image, it's going to certify that this image has been built by Cloud Build. It's going to attach a metadata node to that image and sign it with its own private keys. So if it lays there in artifact registry, and then when Cloud Run picks it up again to deploy it, it will look at that signature, make sure it's there, and then only then it's going to deploy it. There's other things you can do. So you can theoretically do this on your own kind of Google foreign build system. Just import the key material into the cloud and create your own signatures, right? You could also create different attestations. Like, for example, during your CI process, you want to run a vulnerability check, your own. And if it's below a certain threshold, only then you're going to sign that attestation for the image. Okay? And then later on, things like GKE and Cloud Run, they can prove that this attestation is there. Right. And I'm going to show some more code. So this is cloud, so there's a lot of YAML stuff around. Binary authorization. So in any GCP project, there's actually a default admission rule. Well, it's there by default. It doesn't look like that. So in this case, I'm overriding the default admission rule in binary authorization. And I'm resetting it, changing its evaluation mode, so actually require that an attestation is there. I'm defining a rule here. And the enforcement mode should be set to block the deployment and warn me on the audit log. And the attestations that I'm looking for is, has this image actually been produced by Cloud Build? Okay. So if I just update this, like here, no, yeah. If I just update it like this, gcloud container binary authorization policy import that document, I'll just override the default rule. That's not going to change anything. I can still deploy to Cloud Run with a locally built image, for example. But I can use an organization policy and set it so that a particular constraint only ever allows the binary authorization default to be the allowed value for any type of deployment to Cloud Run or GKE, respectively. So let's test that. So what I'm saying is that whenever in this project where this org policy is active, whenever I'm trying to deploy to Cloud Run, any service, even if it's a new service, Cloud Run will enforce that default admission rule that I just installed. So before, I built a local image on my own Docker host, and I uploaded it to GCR. So it's not something that Cloud Build has produced. Right? So you can see it here, Docker push to GCR. Okay, first thing I'm going to try. It's my shell. Didn't actually copy anything. Right. It's a very standard gcloud run deploy this image as a new service command. Paste it in, run it, fails immediately. Why does it fail? It says that the organization policy constraint run allowed binary authorization policies has been violated because binary authorization has been set to null. And remember, I installed that org policy and it's enforced to be set to the default admission rule. So it tells me that from now on, every time I want to deploy, I need to include this flag called use binary authorization policy and use the default rule. And I run that again. Still trying to deploy this locally built image, still fails, right? But this time it says, hey, I looked at your image, but it's not authorized by the policy, right? So there's no valid attestation attached to that image. And if there were, it is for sure not signed by Cloud Build. And that's kind of the thing that I'm looking for. And if I were instead to kind of like fall back to the image that I've just built previously, like probably half an hour ago, and try and deploy that, it's just happily going to do that, right? Because the attestation is present for that image. So this kind of avoids this whole dilemma where somehow kind of somebody circumvents your build system itself and directly just pushes something, maybe even a disgruntled coworker is just pushing something to production because he could, right? In this case, he can't because he doesn't have the cryptographic key material of Cloud Build. All right. Cool.
Question there, so you mentioned it's applied at the project level. What
Yes.
recommendations? You give folder level, domain level.
Whatever floats your boat. If you have, if you're using organization or if you're using resource manager and you have kind of like a tree and you put all your production workloads in this production folder, folder level is probably a good idea. If it works differently in your company, then something else, I guess. It could also be part of your landing zone deployment, right? So if you have a machine that spills out GCP projects, and if it ends in -prod, then it's going to enforce these things. Okay? But that's essentially how it works. So I hope that wasn't too confusing. I kind of carried you like all the way through this thing through. Right? Remember that you can, apart from workstations, all of these things will not drive your Cloud Build app. Right? And you can use these things in a modular fashion. So if you feel like there's a lot more that we could do in how we're pulling open source dependencies, maybe start with a short open source software first. If you see that a lot of your developers are injecting odd, outdated, vulnerable dependencies, maybe start with Cloud Code first, source protect.
Is there a way to add or to request packages to be added to the process?
Good question. I can probably share an email that I shouldn't be sharing, and then you can ask there.
There's some sort of form or request to add some packages to it.
Yeah. So what they're going to do over time is they're going to look at download stats, right? So what are the most requested popular open source dependencies, and then start fuzzing them, right? So Flask obviously is one. Well, the Unicorn didn't really make it to the preview version. But yeah, it's a good question.
The
Cool.
question with the binary authorization, where you say, okay, it has to be built by Cloud Build, but as long as I can, like the malicious coworker, couldn't they just trigger a Cloud Build and then use that image? Like they can still control what source goes into Cloud Build, right?
Yeah, you could. You could.
Would you verify that Cloud Build has to be triggered from your Cloud Code something, or is that not really, like you
But
can't
that's
trace
going
it?
to have the bill of material, like the report that you have, which kind of gives you a little bit of an idea of what's in there.
So if I
Can
would,
you enforce that it only runs it if that bill is there?
so in this case, what I'm also doing is the person who can trigger Cloud Build can't deploy to Cloud Run anyway, right? So only Cloud Deploy does that, right? Right. So there's permissions, and then there's mathematically verifiable cryptography, and it's kind of like use both. It's kind of like, why is it so overwhelming? And it's like so modular. It's like layer and layer and layer and layer and layer and layer and layer. Also, if you're so I'm using Cloud Deploy, right? So Cloud Deploy is using a different interface to talk with Cloud Run. It's using the Knative serving API. And in there as well. It looks slightly different, but you also have to very explicitly supply that binary authorization command, right? So here's a knative serving instruction for deploying that image, right? And it has that as an annotation here, right? And it would be very similar in a GKE version of that would be very similar to that, right? You have to include that or it will be rejected. Cool. So by the way, I'm at the end, so I'm probably also out of time. So yeah.
Cool. Thanks a lot, Dan. That was a fantastic presentation. I certainly learned a lot from it.
Yeah. Thank you.
And I think that given we're kind of like the pieces are already here, if anyone wants to ask Dan any questions, feel free to find him here. Otherwise, I think the food is over there somewhere, and we'll see you in like half an hour or so. See you shortly for the second. 15 minutes? Yeah, 15 minutes then. And if the people that wanted the t-shirts and made the tweets came and see me, I will give them the t-shirt.